If I go ahead and execute this and print the result, comes out 13/27. Wow, where did that come from? So that's surprising. First of all, it's not a third, which you might have thought should be the answer if you believe the argument that Tuesday doesn't matter. And secondly, not only is it not a third, but it's much closer to a half than it is to a third. So just having the birthday there really changed things a lot. How did that happen? Well, I wrote up a little function here to report my findings, and here's its arguments. You can give it a bunch of cases that you care about, the predicate that you care about, and whether you want the results to be verbose or not, and just prints out some information. And by the way, as part of this, I also looked at the question of what's the probability of 2 boys given that there's 1 boy born in December, so I threw that in as well. And here's the output I get. 2 boys given 1 boy is a third. 2 boys given at least 1 boy born on any day is still a third. And born on Tuesday is 13/27, and born in December is 23/47. Now I can turn on the verbose option to report. In that case, here's what I see. The probability of 2 boys given at least 1 boy born on Tuesday is 13/27, and here's the reason. At least 1 boy born on Tuesday has 27 elements, and there they are. And of these, 13 are 2 boys, and there they are. And so you can't really argue with that. You can go through and you can make sure that that's correct, and you can look at the other elements of the sample space and say, no, we didn't miss any. So that's got to be the right answer. It's not quite intuitive yet, and I'd like to define my report function so that it gives me that intuition. But right now, I don't have the right visualization, so I've got to do some of the work myself. And here's what I came up with. We still have the 4 possibilities that we showed before, but now we're interested not just in boys, we're interested in boys born on Tuesday. So there's going to be some others over here where there's, say, a boy born on Wednesday along with some other partner, maybe a boy born on Saturday. But we aren't even considering them. We're throwing all those out. We're just considering the ones that match here. And like before, we draw 2 circles, one of the right-hand side of the event of the conditional probability. And so how many of those are there? Well, there's 7 possibilities here because the boy has to be born on Tuesday. There's only one way to do that, but there's 7 ways for the girl to be born. So there's 7 elements of the sample state there. Likewise, 7 elements over here. Now, how many elements over here? Well, here, either one of the 2 can be a boy born on Tuesday. So really, we should draw this state as either a boy born on Tuesday followed by another boy, or a boy followed by a boy born on Tuesday. And how many of those are there? Well, there's 7 of these, by the same argument we used in the other case. And of these, there's also 7, but now I've double counted because in one of these 14 cases is a boy born on Tuesday followed by a boy born on Tuesday. So I'll just count 6 here. And so now it should be clear, 7, 14, 21, 6, 27. There's 27 on the right-hand side. And then what's the probability of 2 boys given this event of at least 1 boy born on Tuesday? Well, 2 boys. That's here. So it's 13 out of 27. So that's the result. Seems hard to argue with. Both the drawing it out with a pen and the computing worked out to the same answer. Now, why is it that we have a strong intuition that knowing the boy born on Tuesday shouldn't make any difference? I think the answer is because we're associating that fact with an individual boy. We're like taking that fact and nailing it onto him. And it's true. If we did that, that wouldn't make any difference. But in this situation, that's not what we're doing. We're not saying anything about any individual boy. If we did that, the computation wouldn't change. Rather, we're making this assertion that at least 1 was born on Tuesday, not about boys, but about pairs. And we just don't have very good intuitions about what it means to say something about a pair of people rather than about an individual person. And that's what we did here, and that's why the answer comes out to 13/27.